Hello again! In this episode, I'll be going more over data types. Then I'll explain the basics of arrays and introduce for loops and if statements. Here I've declared and initialized a double, a string, and a char, and obviously an int. So a double is a data type that can hold a decimal value, a string can hold text, and a char can hold a single character. So the way I have this organized is I have these different blocks of code minimized for neatness, and we'll go through each one individually. So type compatibility has to do with whenever you have two different data types, such as an integer or double, and they're compatible enough to be compared or operated together. So because they're numbers, we can add them together. So in this case, I took the integer 5 and the double 3.5, I added them together and I put them into an integer sum and a double sum. So before I run this, think about the math that's going on here. If we're adding 5 and 3.5 together, we know that's going to be 8.5, but because the left operand is an integer, we can't 8.5 isn't an integer, so you can't store an 8.5 into an integer. So in this case, when you have a decimal becoming an integer in this way, it needs to be truncated. Truncating means you simply remove whatever is on the right of the decimal and you keep the remaining integer. So 0.5 would end up being cut off and you would be left with 8. Then, so if I run this, yeah, so you can see that it became just 8, and double sum clearly didn't get truncated since it can hold the decimal value, since it is a double. And I did give the same example down here with multiplication, where I did 5 times 3.5 equals 17.5, but it gets truncated to 17, or the double just stayed at 17.5. So next, typecasting is a useful tool that lets you temporarily change the data type of a variable. Right here I printed D, which is 3.5, and then I used the casting operator, which is you put a data type, surround it by parentheses, and then you put whatever you want to cast. And so in this case, I am casting D as an integer. So this way, D will be treated as an integer in this print statement. So if I run this, yeah, so down here, D equals 3.5, and then whenever I cast it as an int, we get 3 because the 0.5 gets truncated off. It is worth noting that this is a temporary data type change, so D still contains 3.5, but just in this print statement, it was truncated. Like if we were to print it again, it would still be 3.5, so just in this print statement, it will have just 3. Now, a really common reason to use typecasting is to solve the problem of integer division. So I have these two integers, 10 and 3. If you divide 10 by 3, obviously you get 3.33333, but in integer division, the extra 3's get truncated, so all we're left with is just 3. But if at least one variable is a decimal value in a division, so if we were to do 10.0, which is a decimal, divided by 3, you end up getting the correct answer, which is 3.3333. So all I did here was I casted the x as a double right here, and then I divided it by 3, which is the y. However, this next line shows that whenever the way you use typecasting can change how it handles the integer division. So in this case, the this operation is evaluating the integer division first. So we already know that this part equals 3. And so by casting this whole number as a double, we end up taking 3 and making it into a double. Even though this output isn't showing us the 0.0, this technically does equal 3.0, since it was treated as a decimal value. So next I'll talk about arrays. An array is kind of like a list of variables that you can manipulate and access. When you declare an array, you need to give it a data type, a name, and a length. These two arrays both have a length of 5, but I initialized this one with values, and this one's just empty. But because they're both int arrays, it means that they can both hold 5 integers. In general, arrays have index numbers, which is kind of like an ID number for each element starting at 0. This means that an array of 5 elements like this one would have indices from 0 to 4 instead of 1 to 5. To access an element, we use this bracket notation with the element's index number inside. So if I just run this, you'll see that indices 0, 1, and 4 printed the first, second, and last element. When I tried printing out element 5, it gave us garbage information since index 5 doesn't exist. Now, maybe you don't want to have to print out every individual element like this. What if you had a huge array of 100 numbers? Instead, we can create a loop that iterates through each index number. So there are a few ways to make a simple loop like this, but the most popular for traversing an array is with a for loop. A for loop starts with a header that has 3 segments separated by semicolons. First, an iterator, which is almost always an integer, and because our array starts at 0, we initialize this to 0. And next, we have a condition for the loop to iterate. When would we want the loop to stop iterating? We want it to print index 0, 1, 2, 3, and 4, so when it gets to 5, it should exit the loop. So this means as long as I is less than 5, it will iterate, so this is our condition. Lastly, we need I to increment after each iteration. Since we want the index to increase 1 by 1 to print each individual element, all we need is the increment operator from last video. And now our header is done. Now, for the body, we need to give the loop something to execute. So if we cout int array at index I, it will start at I equals 0. Validate that 0 is less than 5, and then execute the body, which prints out whatever element 0 is. And then once the entire body is done executing, I will increment by 1, and the process will continue with I equals 1, and then 1 is less than 5, and so on. But once we get to I equals 4, it'll print the 4th element, and then increment I to 5. At this point, the loop will check, is 5 less than 5? And because 5 isn't less than 5, we finally exit the loop. Now, just to make our output look a little nicer, I'm going to throw in a little space after each element output. Otherwise, when we run this, all of the elements will be stuck together like one giant number. And so I'm going to delete this right here and run this. And there's our array. And notice how, because I didn't have an end-L statement at the end of this, it put the entire array on one line, so there's no new lines anywhere here. Now, what if we didn't want to print every single element? What if we just wanted to print every other element? This incrementation goes to index 0, 1, 2, 3, and 4. But how do we print maybe only index 0, 2, and 4 instead? If we change this to plus equals 2, then that will skip every other index. Or if we wanted to print just indices 1 and 3, we could start at 1 instead of 0, and then if we keep this at plus equals 2, this will print just 3 and 20. And so this shows that there are a lot of different ways that you can manipulate arrays with for loops. Now, what about instead of looking at the index, we wanted to look at the elements themselves? If we wanted to print every integer that is greater than 10, for example, I would use an if statement. An if statement is a very simple tool that executes code only if a condition is true. So if we check if the current element, so int array at I, is greater than 10, then print the element. So now if I, this like here, if I run this, it prints 14, 20, and 19 because they're all greater than 10. But how about if we print a message if the current element isn't greater than 10? An if statement can be modified to include an else statement, which will only execute code if the condition in this if is false. So if I cout current element is not greater than 10. Then we'll put both of these on separate lines so it's easier to read. And then whenever we run it, yeah, so it looked at 14, which is greater than 10, so it printed it. It looked at 3, and it printed the error message, and then 7, it says not greater than 10, then it prints 20 and 19 perfectly fine. And so that wraps up array basics and an introduction to for loops and if statements. Thanks for watching, and I hope you enjoyed this video.